Tell us your name and tell us about your project.
My name is Clinton Davisson. I was born October 22nd, 1881 in Bloomington, Illinois. Today I'll be talking about my famous Davisson Germer experiment.
What were you guys trying to do or find?
My team and I were originally trying to study the surface of nickel, but we ended up demonstrating the wave nature of an electron. We did this by shooting an electron gun with a tungsten filament which is heated to give out electrons, which were sped up by using two electrodes using a potential difference. These electrons were shot at a crystal of nickel which displayed a diffraction pattern on a detector that could be moved. This experiment confirmed de Broglie's theory, which all matter exhibits wave-like properties.
Where did the project or experiment occur?
The project occurred at Western Electric, which is now called Bell Labs.
What other significant events were happening around the world at that time?
Oh, the Roaring '20s was a magical time. I remember the same year of my experiment, Charles Lindbergh made his famous transatlantic flight. Ford also unveiled the classic Model A at this time.
Who else was involved in the project?
Well, as you can tell from the name of my experiment, my good friend Lester Germer worked alongside me in this project. Germer was one of my best friends and was one of the friendliest people I've ever met.
What was your role in the project?
My role in this project was to demonstrate the wave nature of an electron with my good friend and colleague Lester, and then write an article on our findings. I also made some modifications to the tube design and the detector mounting by adding azimuth and coltitude.
What impact did your project have on the physics community?
Well, the findings of my experiment set the foundation for modern quantum theory, which is arguably one of the most groundbreaking discoveries of all time.
At what moment did you realize what you were working on could change the world?
I would say in the summer of 1926 at the Oxford meeting of the British Association for the Advancement of Science, when Max Born gave a lecture based on my own research of refraction curves. This is what motivated me to go back to America and modify the vacuum tube and detector to try and make a breakthrough.